Oh, should have bought sunglasses. Okay, hey everyone. We're going to get started for this, the first of two Hive sessions over the next 2 days. Design for Planet in Action, Fabrication, Futures and Frontlines. That's today's session. My name's Joe Isles. I'm the Design Activation Lead at the Ellen MacArthur Foundation. We're an organisation that accelerates the transition to a circular economy. You don't really need to know much about me, other than I'm just going to walk us through the amazing insights and presentations over the next 90 minutes, and same again tomorrow. Thank you for joining in the room, and a big hello, wherever the camera is, to the people watching online, because these sessions are being streamed as well. So hello, and thanks for joining to the online audience. Over the course of the coming presentations, this is a bit of housekeeping. Please use Slido. It's in the app, and make sure you're logged into the correct room. This is Auditorium 1. So you can use Slido to ask questions or to boost the questions that you think are pertinent and that you want to see get asked. So boost the questions you want to see asked. If we have a Slido malfunction, these microphones have been placed on the edge of the stage, and we can go old school if we really need to. But I'll come up at the end of each of the presentations for about 5 minutes to ask some questions from you. Last bit of very important housekeeping. There's no break in this session. So if you need to use the facilities, use the bathroom, please just come and go as you please. They're below this auditorium room. So just exit out the door, speak to someone from the Barbican if you get lost, and we'll send out a search party if you're not back within about 10 minutes. It's pretty straightforward, I think. Okay then, let's jump in, because we've got quite a lot to get through over the course of this Hive session. Firstly, we're going to ask the question, how can we radically reduce concrete's environmental impact while expanding its design potential? 2 experimental structures from Zaha Hadid Architects are rethinking the use of concrete for a circular future. It's about cutting waste, eliminating reinforcement and enabling reuse, but it also brings together architecture, engineering and technology. And to tell us more, let's have a round of applause and welcome Shajay Bhooshan, Associate Director at Zaha Hadid Architects.
Thank you. Yeah, thank you for the introduction, and thanks everybody to joining me here. So I'm going to talk a bit more about like how design is instrumental to a sustainable practice, and we're going to talk about concrete, like, which is, as everybody knows, is one of the most used materials, and how we can make that more sustainable. So I'm going to talk more about building more with less, and we're going to go through 2 case study projects. The first one is this one, which is a experimental structure that we built in collaboration with the Block Research Group in ETH in Zurich, and our company, Zaha Hadid Architects, with a small startup that is pioneering a lot of 3D printing with concrete in Austria. And Holcim did the material engineering. So what's interesting about this project is there is no steel in any of the structure. It's entirely dry assembled, and so which means it can be disassembled, which eventually it was, and it can easily be crushed, which again it was, and recycled and so on. And so the only bit of steel there is in this entire structure, which spans about 16 meters, is in the steel footings that you see. And so it's an entirely unreinforced masonry structure, which is like a stone structure composed of 3D concrete printed blocks. And I will run through a little video that gives you more details. So the entire construction process was less than a week, and the design process was maybe about 3 months. And you can think of like Striatus like this as a masonry structure with artificial stone, meaning concrete can be thought of as a artificial or synthetic stone. So everything that we were able to do before with stone, we can now do with concrete and more. And instead of cutting and assembling stone, like here, we are printing the stone and then assembling it. The rest of the properties still remain the same. And like what that means is, like here you can see in the video, like there were 53 blocks of stone, like artificial stone that were printed, and each block takes about an hour to print. And then they were assembled, so they were altogether about 84 hours of printing. Here, and you can see also because we are printing, most of the block is hollow. Unlike stone, unlike real stone, we can place material where exactly it's needed. So most of the cross-section, actually, you don't need concrete, and that's how you can save a lot of material, which otherwise wouldn't have been possible if you poured the concrete. So altogether, it's a fast way to build, like and also you don't need formwork or a mold into which to pour concrete. So that gives a lot of benefits. And the other thing is that it's easy to transport in smaller pieces, and you can see that the construction site is extremely lightweight. All we needed was a spider crane, and everything can be lifted like with human labor. There were about 5 people building the entire structure. And within a week, we were able to erect the entire structure. And anecdotally, like when it was demolished, like all the people petitioned the mayor of Venice to keep it there permanently. And it was the engineers who got cold feet because it wasn't designed for permanence. But like this highlights like the few uses of like a pathway of how design can be instrumental to reduce the amount of material to make the structure repair friendly, which most modern structures are not repair friendly. So here you can take off a block and put a new block in. It's also very reuse friendly because you can crush this concrete very easily because there's no steel embedded in it, and therefore it's also recycle friendly. And like as a critique, like we did another version, like we said, like if the structure is so sustainable, but like what is not so sustainable is like the formwork or the timber that supports the false work that supports the initial erection of the concrete structure. In order to also reduce the amount of carbon footprint of the concrete, we designed a newer version. We did more analysis, including LCA and so on. And then we bid from Striatus, we designed a more sleek, you can see much thinner, much shallower angles, a new structure called Phoenix. This is designed for permanence, and this was built again for taking measurements and also how it settles. It was engineered, it passes building code like in France, which is one of the strictest building codes in Europe. And this is in the research facilities of Holcim in Lyon. And so this is almost ready for commercial application with these two kind of prototypes. And the ink that came that was used in Phoenix came by crushing the stone that was used in Striatus. And then we made that into ink and then reprinted the new blocks. So this is also a way to recycle material and print it again somewhere else rather than transport the printed blocks. And so you can see like the amount of false work has also been reduced from Striatus to Phoenix. Like all the false work is reusable steel false work, modular false work compared to the custom-made timber false work which was needed for Striatus. And the other thing which addressed, like as a process of all of these, we already reduced the amount of carbon footprint by about 30%. And like we potentially also can save furthermore when research further advances. And so like in both these kind of case study projects, what we realized that design is kind of instrumental to a sustainable future. And I'm going to highlight 4 key points of what we learned. Like, one is that design is instrumental, and sustainability is less about material and more about designing the right shape, which is somewhat counterintuitive. And that also that digital design is like fundamental to be sustainable, and then that also design should be collaborative and research oriented. So starting with design is instrumental, like why do we feel that? Because 3D concrete has a lot of promises that it makes, including reduction of resource, increased productivity, increased worker safety, and so on. But like only designers have to then ask, like, how do you make this technology, which has not really changed since the 1950s, just like it's the same technology, whether it's the material side or the digital design side, both have been around since the 1950s and 1980s, and nothing changed. So how do we actually engage with this new technology and kind of bring it to mainstream application? And so we figured out that typically design is absolutely ignored because most people are focusing on like the rest of the technology, like the material engineering, like the hardware development and so on, and most people forget like that design is an integral component and it shouldn't be relegated to the top left corner. And so we then decided, like, how do we work backwards? How do we inject design right into the production process so that it's not extraneous to it? It's not, so it's integrated. So we said, what does the robot need in the end, like, and work backwards from that. So the robot goes layer by layer and places material. So like, how do we inject design into this process? So we work backwards, like, okay, then we need to design the blocks, and then we work backwards. We need to assemble the blocks into a stable structure. So we came up with this kind of process that goes from design all the way to production. So there's nothing extraneous to what the robot actually needs to print the structure. And the second thing that we realized that, like, sustainability in design and construction is actually depends a lot on the shape. And even though concrete has a lot of bad press, let's say, in this case, like, the way to make concrete more sustainable is to design a shape that is better suited for concrete. And there we learn a lot from like nature and like so-called thin shell structures. Eggshell is a classic example of a thin shell structure, which is very, very thin, but because of its shape, it can carry a lot of force. Like, and if you try pressing an egg along the longer direction, you will know how strong it is because of its oval shape. And that's exactly the principles that have been used for millennia, like here in King's College Chapel. The stone is as thin as an eggshell comparatively by proportion for the amount of length of like span. The stone is like only 5 to 6 centimeters. It's as thin as an eggshell in that sense. And you can also see it's elegant and beautiful because of like these structural principles. And so that's what we set out to do, like incorporate these ancient principles, ancient wisdoms into giving concrete a new language compared to the brutal and cast language that was popular in the 20th century. We wanted to give it a striated language based on the additive manufacturing. And the other critical point I want to make is that sustainability, the first step to that is making your design process digital. And it's not as easy to think about it because like a lot of stone structures were designed already pre-computer without computers and without like numerical calculations. And how did they do it? So we like looked at these geometric principles, like all of these structures, beautiful churches, were designed without a computer, without like numerical calculations, with so-called geometric calculations, as you can see here in the diagrams on my left. And we therefore decided to incorporate these principles of laying material in geometric patterns, and then also combine it with robotic manufacturing to get to this kind of design process that allows us to design contemporary shapes beyond like arches and vaults, beyond what was possible a few centuries ago, to these more fluid shapes. But they all have the same principles as the churches of the past. And so digital also allows us to search through many more options than we might have otherwise done in a manual process. So we can design many structures, like, and choose the ones that are best suited for the context, and so on. So, and lastly, I will end with this topic where design must be collaborative, must become more research-oriented, and that also means we have to start with playful beginnings. So the way we came to all of these digital processes was to gain physical intuition by squirting wax in this case. And you can see it like when we were squirting wax on a cold Sunday afternoon in London, you can see that the shapes that it naturally takes are these arched and vault-like shapes. And so that then kind of gave us the ideas to replace our hand squirting with a robotic hand that squirts instead of wax like some concrete. And then we had to build up tools to make that happen. And like along the way, we also, like I did my PhD on that topic, and then realized that like we can tap into like centuries worth of wisdom in masonry construction and digitize a lot of that, many of which has already been done by my colleagues elsewhere in the world. And so you can see like just the last 10 years, all of this work has become more and more mainstream, available on a computer, like for almost all of us to use. So like that's where we are at. Like we started with 2021 with this bridge, and then we did another one in 2023, and now we are trying to commercialize this technology and also apply it to other structures rather than footbridges alone. So this is a proposal we made for hydrogen refueling stations. And so again, to reiterate, like this is where we think design is instrumental to envision a future with even a material that is as polluting as concrete, that design can actually have fundamental impact in making materials more sustainable, but also lending a new visual language, a new identity to a very well-known material. Thank you very much for your time.
Thanks, Shajay. I loved that. One thing I loved about it is that in promoting circular economy for the past 15 years, something I always hear is, that sounds like my grandparents used to do it. And it's sort of frustrating because actually there's something that is sort of in principle true, but then it's sort of a philosophy that has been revitalized by technology, actually. And there's certain ways that we can design, build, interact with the world around us that would look like complete science fiction to our grandparents. So it's this sort of infusing of the old and new, which I thought came through really strongly in that, of saying, yes, this is 3D printing, it's digital fabrication, but inspired by the churches of centuries ago, or even ancient biological wisdom of an eggshell. So so much in that. I hope you enjoyed it as much as I did. We've got a few questions that have come in on Slido. Top question, which was mine actually, so I'll take credit for that. Do send your questions in on Slido for our speakers. There's some more dropping in now. You touched on it a little bit at the end there. But the question I had was, how can you move from showcase, which you see this from architectural firms quite often, but how can you move from a showcase to a business case?
Yeah, good point. So this was in 2023, and now we are working with the European Union so-called Horizon projects, like it's called carbon negative structures. And here, the way to commercialize it is to first point out that a lot of the knowledge needed is already available, and we're kind of making most of these tools that previously took a PhD worth of research to make, now it's available in ready-to-use open source platforms and so on. So that's one step we think is necessary to make these technologies applicable in places like India or Africa. like I'm originally from India, and like I see when we built the first structures, like most of the inquiries came from India, or places like India. Why? Because like all it needed was a robot, right? And the robot's actually relatively cheap, and like concrete is well known, and then you just need a computer. Like so, and places like India are actually using a lot of concrete printing now, and also because there's masonry knowledge also available in like more ancient cultures. Almost every culture knows how to build with brick, like and stone. So yeah, like I think like business cases come from initially just pointing out that like this is actually applicable. So demonstrators really are influential in the business case. Having said that, like the Block Research Group and Zaha Hadid Architects, we're also working with the European Union to make commercially applicable structures. Like the Block Research Group has made a floor slab that uses similar principles, 70% less concrete, like about 90% less steel, and competes for cost with a hollow core slab. So yeah, once design becomes research-based, like the pathway to a business case is relatively short. Like as you can see, from 2020 to 2025, there's already many startups that are building on this research.
Okay, great. You mentioned that example of the block, the slab there from the research lab. Another popular question: how does the cost of production and construction compare to traditional concrete structures?
I mean, in principle, it should be significantly less because we are using about 50% less concrete in the blocks. And in addition, like we're wasting even less because typically you have to mix concrete and then pour it, and most of it is actually wasted because of wet construction, right? Like a construction site, a lot of it is spilled over, and then you have to clean it and so on. So by precisely placing concrete like in these layers, like we are reducing a lot of concrete in general. And then we're also reducing a whole lot of steel because we're using these principles of eggshells. But the way it's difficult to compare is because like the two shapes are very different. Like if you were to design a traditional concrete structure, you wouldn't make it arch-like. So therefore, it's somewhat comparing apple with oranges. But
I guess you're also at the sort of bleeding edge.
Exactly.
And so comparing that to very highly optimized concrete casting that's going on every single day.
But the floor slab actually compares with like compares very well with like traditional floor slabs.
Okay.
Actually, much cheaper. Yeah.
A technical question: what's the actual material being cast for the blocks? Is it concrete or stone? If the former, something's jumped around, how do you address the embodied carbon issue?
So yeah, it is concrete, like, and it's actually the polluting part of concrete is the most polluting part of concrete is steel, and the second most polluting part of like reinforced concrete is the calcination process of cement production. And so Holcim are doing a lot of work in reducing the carbon component of that particular process, and then also using recycled concrete for aviation fuel and so on. So the material side is being engineered, like, and concrete is one of the most engineered materials for like hundreds of years. So that is being addressed. And like as designers, how we can address the embodied carbon is to do two things. One is to reduce generally the amount of concrete used, and so we are using these masonry principles to reduce that material quantity by orders of at least half, and we are also reducing the steel more than by half. And the other thing we can do is make the structures a loved structure, like that people actually want to use it and don't want to demolish it, because most concrete structures, if they're left to are typically demolished well before their expiration date. And if they're not demolished, concrete can actually eventually absorb all the carbon that was used in its production back from the atmosphere. And that's one of the principles of concrete, why it is very useful to dump concrete into the ocean, it will still absorb carbon from the oceans. So yeah, if you increase the longevity of your structures and reduce the amount of concrete consumed in general, like that's what we as designers can do, whilst the material engineering is definitely progressing rapidly. And I would encourage people to look at the Holcim websites and other cement manufacturers. Yeah.
I'm just going to take 2 more questions from the Slido. They flooded in, so thanks for that. We're going to merge a couple. So someone's asked, how does this impact the Zaha Hadid Architects image? What happens if it fails? And I was also thinking, as you were presenting, what is driving this? What do clients make of this, or what do you think how they respond to this type of innovation? Are they asking for it?
Well, I mean, Zaha always said that experimentation should never stop, and so I don't think we have much fear of failure. That's not. I mean, it's one of the beautiful legacies of Zaha that left us as a company, that she always encouraged fearless experimentation. And so, yeah, many times we fail, but like we don't fail like in the eventual analysis, right? Like we learn from failure, we make the next one. And so like, you know, the first one that we did, like it took 6 months. The next one we did took like about 3 months, and so on. And so we learn a lot like by failing, in fact. And so we think of it, failures are almost necessary to succeed in this kind of research-oriented way and experimentally. And clients don't directly ask for these things, but once we make a physical demonstrator that people can touch and they can see that it can be used, and people love to use that structure. Like it was in the middle of Venice. It was not part of the main Biennale, but more people visited this one than the actual Biennale. And they made the people around those houses, they petitioned the mayor for it to be a permanent structure, and so on. So then clients see this kind of publicity and this kind of value, and that's how like Nat Power came to us, and we were able to convince them that like we can use these experimental technologies to realize their projects, because no client wants to be the guinea pig, right? Like or they don't want to pay for experimentation. So we need to take on these risks collaboratively and work with universities, work with researchers, and kind of bring the vision to life over a decade now. Yeah.
Last question then. What's next in the world of 3D printing? It feels a bit unfair to ask you that, seeing as you've just brought us up to the frontier, but someone's saying, what's next in the world of 3D printing in terms of materials and techniques?
Yeah, like the key message is like look at the past to look at what's going to be next. So everything that we have done before in stone, but we have lost, because building with stone takes a long time, because you have to cut stone and you have to quarry it, and then you have to shape it and so on. But with this kind of liquid stone, you can do all the beautiful things that you had done before and more in shorter amount of time. So the next thing is for these things to become part of everyday housing, for example, in floor slabs. We are also promoting the use of this kind of structure for the bottom floors of many of these residential buildings, so-called 5/1 housing, because the bottom floor in North America is already made of concrete. Why don't we make it out of this? Because concrete can carry a lot of weight. So you can build 10 stories on top, and it wouldn't even flinch, right? Like you don't need to put any more concrete. So these are some of the applications that we are now seeing can be reinvented, like which previously was done in stone, but we can now do it more sustainably. But we get the benefit of all the beautiful spaces, like the Grand Central in New York, or like King's Chapel. We can have these kind of spaces without spending a lot. Yeah.
Wonderful. Mm-hmm. Round of applause to Shajay.
Thank you.